Hi, everyone. Welcome to Oracle's Hands-on Lab. Today, we will be learning about analytics and machine learning using Red Bull Racing data. Just a quick start off. My name is Charles Yup, and I am a senior architect from Oracle's SE Hub Kuala Lumpur hub, right? So I have a little bit of experience on analytics and also data integration as well. And today I would like to sort of bring through you on the agenda where we're going to start off by setting up the Oracle Cloud tenancy. And moving forward from there, I would then show you what would be the current sessions flow in this hands-on lab. And eventually we'll head straight on to the lab sessions. But before we even begin, here are some lab details where you have the lab URL and also the public Slack URL. Let me just paste that into the chat right now so that all of you will be able to access the lab guide. And hopefully, as we go along, you'll be able to follow the steps as well. So, yep. Now let's go right into setting up the tenancy. If we go straight into the lab guide, we actually, let me just bring you through, right, what it looks like. So at the initial step of the lab guide, it sort of gives you a tab called Getting Started. So over here, you're pretty much be able to create your free trial account by heading to cloud.oracle.com, and there will be a link where you could click into it to register for free. So as a free participant, as a participant that register for free, you will get 30 days free trial with $300 in free credits, where you'll be able to try all sorts of Oracle Cloud services for the next 30 days or until the credit ends. So what you actually need is a valid email address along with a phone where you can receive the SMS text for verification purposes. So like what I've said, you can go to the link here, oracle.com/cloud/free. And eventually when you reach to this page, it will ask you for the confirmation, for example, the country or territory, along with your first name and your last name, and of course, your email. So eventually you'll be choosing your country, pop in your name and your email, verify the email button, and eventually you would have a screen that would tell you email verification link is sent. So you'll be able to log in into your email account. You would see an Oracle email that's being sent to you with a link, right? And you'll be able to see the validation. So when you click on this link, it will help you to validate your account and sort of kickstart your account to start running up for you. So if in any case you're not able to find this email, you might want to check the spam or junk folder just in case. And eventually, once you have clicked on the link, it would start to kick off the process where you can create your account. So it will ask you to choose for a password, put in your company name, or if you don't have one, that should be fine as well. Eventually, you would want to choose a cloud account name. So this is pretty much like a typical username for your cloud account, where you could choose it and it will be assigned as your tenancy name as well. And eventually choose a home region where probably be closer to you. So in terms of the connectivity, it would not have too much of a problem in terms of latency. And eventually we can click continue. So once you click on continue, you would then be required to add in some address information. along with the mobile verification number as well. And if I'm not mistaken, in terms of the payment, that should not be popping up for this session since Jane probably would have whitelisted the accounts. So eventually, once that has been done, you can click on the tick here for the agreement. Of course, you probably would want to read it as well. And eventually you can click on Start My Free Trial to start the trial. And not long after that, you will be receiving another email from Oracle that would tell you that your Oracle Cloud account is now fully provisioned. I have a question from Arnab. I think we should have a batch link as well. We'll probably put it into the chat later on, right? And eventually, once you have this email, you can now sign into your cloud account, and we can actually, get started with the lab. So while you kickstart the process of registering for the cloud account, it will take a little bit of time to get it fully provisioned. So now we can get back into one of our sessions here when it is more on the session flow for this hands-on lab. So eventually, I will bring you through the tenancy setup, which I have just did. And we would then start to provision the analytics cloud, followed by provisioning the autonomous data warehouse. So once we have the data warehouse provision, we can eventually load the data into the autonomous data warehouse. And this will be eventually the previous F1 live data that has been collected over the years. So once we have loaded into the autonomous data warehouse, we would then be able to connect this autonomous data warehouse into the analytics cloud, and we can start to do some basic data exploration, right? And eventually, once you have the basic data exploration, probably you would want to do a little more advanced, perform the advanced data exploration as well. And eventually, we will come to a point where you would want to do a feature generation from the machine learning algorithms. And eventually, once the machine learning algorithms has been established, we can then start to do the machine learning training to get the final algorithm or the model. So eventually that model, we can use that for prediction and evaluation. Right. Without further ado, let's go straight into the lab sessions. Just give me a second. Okay, so this is the Oracle Cloud page when you first log in into Oracle Cloud. And eventually you can see we have like a number of services. And one of the key things that we want to start first is the analytics, right? Go into analytics and AI and click on the analytics cloud. So over here, you'll be able to click on create instance, and probably you just want to put a name, right? So let's say I put Red Bull OAC, and eventually in terms of the capacity, you can just leave it as a 1 OCPU along with a license included. And you just click on create. All right, so now we have triggered the process to create the Oracle Analytics Cloud. We can now jump right into the Oracle database and click on the Autonomous Data Warehouse. Over here, we will be creating the Oracle Autonomous Data Warehouse. And once you click on Create Autonomous Database, it would give you some basic information like what is the display name, You can leave it as it is, or you can make it a more user-friendly name. In my case, let me just put Red Bull, ADW, and eventually we can choose the workload type. Now in this hands-on lab, we'll be going with the data warehouse. And in terms of the deployment type, we can go with the shared infrastructure. So the rest of the configuration, you can actually leave it as it is. And eventually when it comes to creating the administrator credentials, this is where you would need to set a password for your database, right? So I'm going to set a password, make sure they are the same to at the confirm password field. In terms of the choose network access, we can leave it as it is. And the license type, you can choose a license included. And eventually, in this case, if you want to get operational notifications, you can put your email as well. So in my case, I'll put my email and I can click on create autonomous database. It would start creating the database. Right, so as you can see, once you have create the autonomous database, it would start to show you this page, and the status now is orange, saying that it is provisioning. So it'll probably take 1 or 2 minutes to run before the resources will be provisioned. So in any case, if we were to check on the analytics cloud, that would take a little longer compared to autonomous data warehouse, probably around 5 to 10 minutes. But of course, the data warehouse would be provisioned much quicker. So we can actually proceed going into the data warehouse first, because eventually what we need to do next in the lab, let me just scroll through the lab to show you what we need to do next. So we have actually jumped right ahead for lab 1, which is to provision the analytics cloud, right? Login with a federated user login. You should be able to provision the analytics cloud. And eventually, once you have login, this is where you create the analytics cloud. And eventually, we will go to the next step, which is to create the autonomous data warehouse. So having said that, once we have actually created the autonomous data warehouse, we will actually be heading to lab number 3, which is to load the data, right? So in lab number 3, you will notice on task 1, we actually do have some administrative tasks that we will need to do first, which is, let me just check in terms of the instance, if it's ready or not. Okay, so now we are ready, and we can actually get back to the process where we, create a database or with a user schema and whatnot. So we can go ahead, click on the database actions, right? It would launch the database actions menu, and this is where we could actually create the usernames, or click on SQL to do further queries as well. Right, so inside this database actions, we can click on the SQL, and eventually in one of the steps, it is asking you to sort of download a SQL file, right? So go ahead, download it, and you'll then be able to open it. You will see there is a bunch of SQL codes that will be useful to create the credentials. So I'm just going to copy and paste it here, right? So what you would usually do is, what I usually do is I would just select this part where it's actually helping you to create a username called F1. So select that and click on play. And eventually there will be a query feedback or result telling you the user F1 has been created, grant has been succeeded, and the whole PLSQL procedure has been completed. So eventually we can go right ahead, select the rest, and click on play. And what it actually does, it would create all these tables, right? So it is created inside the F1 schema. So if we click on the highest drop down, this is actually the schema drop down. And if you check for the schema, probably you'll be able to find the F1. If not, most probably it has not been refreshed yet. So let me just do a quick refresh. And eventually you will be able to see the F1 schema. So let us try that again. Yep, there we go. We have the F1 schema. And if you click on the tables, you can now see all the tables has been created, right? So based on the first lab, we have actually created all this table under task 1. And eventually, you can go to the next step, which is task 2. So this is where we need to, upload this data, right? Let me just show you where that is. So eventually you'll see under task 2, you have 6 different files. Do download them into your laptop or a computer, and we can start to upload this data into the autonomous data warehouse. So now, if we head back to the database action, let me just get to there. You would see that we actually logged in as an admin. So we actually need to sign out and log in as the F1 user in order to continue loading the data. So as you can see in this SQL, what it does is that it helps to create a user called F1 with the password Oracle 12345, right? So let us just do that, sign out, and we're going to sign in again. So in this case, I'm going to choose F1, right? And eventually put in the password. And now you are logged in as the F1 user. So once you have logged in, you would have some options, the same similar options that you've seen with the previous username admin. And we will be clicking on the data load, right? So inside this data load, it will ask you, what do you want to do with your data? I would like to load the data from my local file. And eventually we can click on next. So let's go ahead and click on next. And now it brings us to this drop-down area where you can actually drag and drop your files, your data files into this whole area here. So I'm going to do just that, drag all my 6 files, pop it in. And now you see that there will be 6 rectangles that will represent each of your files. Eventually, it would appear and you'll be able to edit the data loading configuration. So as you can see, once you pop it in, you click on this pencil, which is the edit menu, and it would tell you that the default option is actually to create the table. But actually, you have actually indeed create a table previously, so we can make use of that table instead. So instead of choosing create table, we're going to go with insert into the table. And right away, it would, select the safety car for you. This is one of the tables that exists in the F1 schema. So we're going to go ahead, click on that, and do the same for the rest of the data files, right? So once you do the changes, you would see the target would change to the exact table name. So let's do that for the rest of the data as well. Change it to insert table, make sure it's the same name, driver standings, and we're good to go. The same goes for the rest. I hope all of you are following along the way. It's pretty straightforward in terms of loading the data, right? And eventually what happens is this data will be the longest to finish loading because if you look at all the file size, these are pretty much like 4 kilobytes, 3 MB, but this one would be around 21 MB. So that would indicate a larger record count. All right, so now we have finished editing all of this. We can actually click on the play button and it will start to run all your jobs. Now, so far, once the job has been completed, there is actually a status telling you how many jobs has been completed, along with a tick indication. So far, we have 3 that has been completed, and eventually more will come. So what happens next is that once we have pushed the data into the data warehouse, we can actually create a connection in Oracle Analytics Cloud in order to retrieve the data from the autonomous data warehouse. Now, as you can see, it will take a little bit of time, so that should not be an issue. In the meantime, we can try to check on our analytics instance and see if it is ready for use. As you can see, it is still taking a little bit of time to create the analytics instance. So anyways, let's get back into the autonomous data warehouse. You can see that it is reaching to its target in terms of finishing loading the data. So great, now we have the data loaded. We can actually proceed to the next step. Well, hopefully, we would have finished creating OAC by then. But for those of you who wonders, how do you access? Well, eventually, once this instance has been created, we actually have an access information here where you could use this URL, or you can even copy it and head on to the analytics instance. But I think as of now, it's not ready yet. Yeah, it's pretty much taking a little bit of time, like I've mentioned, around 10 to 15 minutes. But that should not be an issue. I mean, we're pretty much ahead in terms of the hands-on lab. But just to give you a quick idea, what is next for the hands-on lab, let me head on to the lab guide. As you can see, we are now approaching to lab number 4, where we are supposed to create a connection from the autonomous data warehouse into the analytics cloud. And one more thing before we even do that, let's head back into the autonomous data warehouse because we actually do need to download a wallet. So if we click into the autonomous data warehouse, there is actually an area called DB connection, right? So this is the wallet that we need to download in order to retrieve the data by creating a connection in the Oracle Analytics Cloud. So I'm going to go ahead and download this wallet. And in terms of the password, you can put any password that you want. Just make sure you have it saved, right? So I'm going to go ahead and click download. So right away, you have this wallet you have downloaded, and you're going to be using this wallet to create the connection. So let's head back again to Analytics Cloud and see if it's ready. Okay, here we go. Now we can actually click on use this link, or probably we can click on this button here calling Analytics Homepage. And now we are in, and it is loading the Analytics Cloud. So eventually, like what I have said, you would need to download the Oracle wallet. That is actually the credentials to gain access into your autonomous data warehouse. So based on Lab 4 Task 1, you would see you would actually have to create a connection, right? So on top of the page here, click on Create and click on Connection. So you could now see the amount of connections available that you could actually create. It's taking a little bit longer than usual to load. Okay, here we go. So we are going to choose the Oracle Autonomous Data Warehouse, and you can just put any connection that you want. Probably you can put Red Bull. And what you can do, since I have downloaded and the wallet is here, I can actually drag and drop, right? And eventually pop in the username and password. So since your data is located in the F1 schema, we can put the username as F1 and also remember your password. So yeah, you can stay with the service name hi, and eventually we can click on save. So now that you have created your connection, we can start to add some data sets from the connection. So there are two ways. So based on the lab way, you can click on create dataset and choose the connection that you have just created, which is Red Bull. So once you click on that, you would have to browse into the F1 schema. And you can see I have races in. So I can just drag and drop, and it would start to tell me what would be the overview of the data in races. So when it comes to the races, you see that each record of the data set will represent a race on the Grand Prix. And you can see how Oracle Analytics actually profile the data for you. Right, so now you can see what that actually looks like. And if you were to look into the years, you can see these are the typical years that came around. It's quite a large collection of data that has been collected over the years, right? And if you look at the year column, you'll notice like what has been mentioned in the lab guides. The Formula One starts from 1950 all the way to 2021 session. And also, if you look in the score, some would have the scores and some would not. So in detail, you would see that now that we have the data set, we can actually click on this races here. It would then show you the representation of this races data set alone. And if we click onto the Metadata tab, which is this button here, we will need to change some of the columns here to a certain different treatment from what it was initially being initiated. So in this case, you would see that we have a race ID. It should not be a measure. It should be an attribute. So I'm going to change that to attribute. And along with the other stuff as well. So if you can see, there is the race ID, there is the score. Okay, so in terms of the score, we would want to change that into an average instead of a sum. And eventually we are good to go. So we are now ready to save the data set. So just click on save and put it as races. Okay, so once we have saved the data set, it would then appear inside the dataset tab, or if you click on data, right, you would see races here. Or another way to navigate is to go into the data, under data sets, you can see the races data set that we have just saved. So now let's add the lab times. So again, we repeat the same process, click on the Redpool connection, go into the races, into the F1 schema, and you see we have the lab times. Again, do the similar approach, drag and drop. And this time, Oracle Analytics would profile your data inside lab times. So again, it would do the same actions as it did from the earlier data set. You can now see a bunch of columns like race ID, driver ID, and so forth. So eventually it comes to a point, again, we would want to readjust the data because the initial settings that has been put in place might not be accurate or useful. So again, we click on the metadata and we have a few attributes we want to change. In this case, we'll be changing the race ID. So we're going to change that to an attribute. Same goes for driver ID and also the lab. And eventually that is done. We can click on save, right? Click on save here. Save it as lab times. So again, once you have saved the lab times, we can actually start doing a little bit of, I would say, investigation into our data, right? So if you look into the lab 4 task tree, it is actually asking you to head on to the races dataset. So let's go into the race dataset, right? You can also click on here. Just click on it. It would then open a new workbook for you, right? So what we can actually start off is we can actually create a new visualization. So probably we'll want to choose two things. One is the name year, right? This is the name year. Click on control, click on your control key, and we can choose another column. In this case, I'll be using the score. Right click on that and pick a visualization. Now, it will start to ask you which visualization you want to go with. So most probably I would go with the table icon, which is this. So right away, you can see some of the scores being headed in as well. But eventually we can only show, filter out these records so that it only shows the records with the scores being assigned to it. So I can actually drag the score into up here. So this would be our filter section, right? And in terms of the score, I'm going to set from 0 to 10. So now, based on the data, you can see that we have scores now in the score column. So what you're going to do is you're just going to click on this button here to sort it from high to low. And right away, you can see the 2012 Brazilian Grand Prix is where we have the highest score, which is 9.45. So this is pretty much the best race during the decade that the fan scores were actually collected. So similarly, we can actually look for the race with the lowest score. So it's pretty much by clicking on the top option here, it will sort from low to high. And now we can see that the lowest score is actually from the 2020 Abu Dhabi Grand Prix race. So overall, what I'm going to do is I have some results. I'm going to save this this workbook into all races overview, right? So this is pretty much how you save your analysis. You do a quick analysis, and if you feel at some point it will be useful, you can save it and revisit it later. So I'm just going to go back to the home page, and in this case, we are going to take a look at the other data set, which is the lab times. So again, we just need to click on lab times, and it would then open a new workbook, and we can, go ahead and create a visualization. But before we even do, in this case, we're going to start with dragging the race name into the drop-down filter here. And we are going to search for a few races. So we're going to start off with the 2012 Brazil Grand Prix and probably the Abu Dhabi, right? So we're going to select these two options first, and eventually any visualizations that we try to populate, it will only show from that two races. So we are going to start by selecting the lab. Again, hold your control keys so that you can select multiple columns. And the last one will be the driver reference. Again, right click, click on pick visualization, and click on this line chart. So now this is where we are seeing a lot of information. Now, in terms of this information, it would be more useful if we separate it out by the races itself. So probably what I'm going to do is I am going to click on this race name and drag it into the trellis rows. Uh-huh. So now it is much easier for us to analyze and see what happens within each race. So probably you could start to do a little bit of inspection of the results, and you can see that the high score race has actually many more position changes compared to the low scoring race, right? So what this actually means is that the number of takeovers are actually one of the important factors that would influence the race score. I mean, it pretty much makes sense. And we should actually put a note of that. As we have seen in the lab guide, the first note is the total number of position changes might be a factor to predict the race score. So eventually what this is, why we are noting this down is eventually we will have to define some of the features in the machine learning model or algorithm so that when it does the training, it would consider these factors and provide you the results, predicted results based on um, this factor to, predict the race score. So eventually, what tells us is that it'll be interesting to analyze on the top positions. So let's pretty much zoom into them. What we're going to do is we're going to choose the positions. We're going to drag it up here as well as a filter, and we're going to set it from 1 to 5. So let's change that to 1 to 5. And right away, you can see a clearer picture in terms of the positions. So if we look into the result chart, eventually for the Brazilian Grand Prix, um, we can conclude that it doesn't only have more takeovers in general. As you can see, the positions keeps changing, the takeovers, that keeps happening. It also have more takeovers in the leading positions. So it is quite aggressive between position 1 and 2. There has been an aggressive takeover along the way, right, along different labs. So that pretty much confirms that the takeovers, especially the top positions, are another important factor that would influence the score. So let's see what we can find in the chart. We are going to delete the 1 to 5 positions now, right? And if you look closely on the 2012 Brazilian Grand Prix, especially for Paul di Resta. So let's click on Paul di Resta just here. Okay, so that will be under Resta, Hamilton, Grosjean, and Maldonado. Anyway, search for Resta, right? You click on this, it will tell you exactly which is the actual line. So let me just unselect any of this. Yeah, just hover your mouse there and you can now see, for example, for Resta, what it looks like. For Hamilton, um, can't really see. Okay, there it is. Hamilton is among the top positions. And we have Grosjean. Oh, this is a hard color to see. Yeah, it's pretty much the pale orange color. And eventually we have Maldonado. So that would be that green. I'll probably just click on that. Oh, it's only one dot, as you can see. So anyways, you'll now notice that these drivers pretty much did not finish the race. So for these drivers, they did not finish, and eventually it raises the theory that the do not finish may increase the score that the fans give to a race, right? Um, Eventually, nobody likes accidents, and this probably happens during accidents, and that's why they did not finish the race. But it pretty much, add a little bit of a dynamics to the race and gives the spectators a surprising effects on the race outcome. So eventually, the next note that you would all need to take note of is the do not finish will actually be a factor, might be a factor to predict the race score as well, right? So now what we are going to do is a little bit different. We can now aggregate the information and see how that looks if we, add the races dataset information as well. So in step 10 of your lab 4, no, not step 10, I mean, let me see what step is this. Task 4, okay. So in task 4, step 10, you will see that you can actually add a new data set into this existing workbook. So we have two data sets that we have added previously. And now we're going to add in the races data set as well, right? So once you click on add data set, you have a new bunch of data sets under the races now appear on your left side, which you should be able to drag and drop into the canvas as well. Now, in this case, what we're actually going to do is we are going to create a table to show all the information for the level of races. So I am just going to select all these columns, right? Right click and click on a visualization, which eventually is the table. So now you can see some of the informations here, like overtaken positions total. Yep. Well, they're pretty much scattered across, right? So we have to sort of hunt down for them. So you have the overtaken positions total versus the did not finish due to accident count. So as you can see for this particular race, which is the Brazilian race, we have up to 367 overtaken positions in total. And also in terms of the do not finish races due to accident, there is up to 6 incidents that happen. So once you can see that, you will know all of this information. And again, just to note that the Brazilian Grand Prix was held during rainy conditions, whereas for Abu Dhabi, it was pretty much like a dry condition. So that also indicates weather would, give an effect to the scores of the driver. So if it's a bad weather, most probably there could be a tendency for more accidents to happen, along with the nature of having more overtaken positions that might be, working on top of that in each race. So based on the hypothesis, pretty much the wet weather on average will make a race more spectacular, right? Because you have unpredictable events because of the added weather factor. So note number 4, wet weather may have a positive influence on the score that the fans give to a race. So now we're going to save this analysis to race analysis, right? Just click on the save workbook, and we're going to put it as race analysis. Okay, so now we can get out of this workbook. So sometimes if it takes long to save, there is actually another option to skip it, but in this case, it has completed. So we can just get out from here, and we can head on to the same data again. Now over here, we want to do a little bit of a correlation diagrams for position changes and do not finish races. So we're going to click on races again, pretty much to create a new workbook. Now, what we're going to do is we're going to choose some of these information here, which is the score, right? Name year and overtaken positions again. And this time we're going to choose a scatter plot, right? So we're going to click on this, scatter, and we'll see some information, but it's pretty much in different axes. So I'm just going to swap it up to be consistent as what is seen on the lab guide. So probably we should create a trend line, right? You could right click on this chart, add a statistic, and add a trend line. So you could see that we see positive correlation, which also means that the number of overtakes increase. Generally speaking, so does the average race score. So like what the diagram has shown you, as the number of overtaken positions in total increases, the number of score actually does increase. So this pretty much supplements one of our hypotheses that we have noted down. So now we can actually conclude number of overtaken positions will remain a candidate to train our machine learning model, right? So what we're going to do now is we are going to duplicate this visual. So as you can see, what I've actually done is I have actually Control C and Control V, but in any other case, you can just right click on this visual, click on Edit, and duplicate the visualization again. But in this case, I think we just need two. So I'm just going to delete off one away. So now we have two remaining. And what it wants us to do is, to click on this visual that we have actually copied. And instead of the overtaken position, we're going to swap it with DNF count, right? So we have this. I'm going to swap it away and change it to DNF count. Now, what do we have? Let me just readjust this so that it's easy on the eye. Again, did not finish count increases, your score would also increase as well. Right? So we're going to do the next copy as well. Just going to rearrange them. So now you can see for did not finish count and also score, we're going to drag the second copy now. We're going to change in the second copy. We're going to drag do not finish due to accident count over the few overtaken positions. right? And in fact, the two diagrams between the correlations for DNF count on DNF due to accident count. Right. So probably what I did was a little bit wrong. We should be doing a little bit of a correlation here. Okay. So there's also a correlation, positive correlation, I would say, because as the number of DNF increase, so does the race score. But the angle of the slope of the line is quite small. So when it comes to the score, that does not increase significantly when DNF is increased, not as much as was the case with the correlation between overtakes and fan score, right? So relying on all your scatter plot, eventually you'll be able to do a little bit of Pearson correlation. So let's do something different in terms of the Pearson correlation, where you could choose the score, your DNF count, and also the DNF due to accident, right? You can click on pick visualization and choose the correlation matrix. So now this correlation matrix will tell us something useful where you have all the variables listed within the vertical and horizontal axis as well. And you can say that for each combination of two variables, this Pearson correlation is a number between -1 and 1. Of course, -1, it means there's no correlation, right? 0 means no correlation. -1 means inverse correlation, I would say, a perfectly negative linear correlation. And of course, 1 would actually meant perfectly positive correlation. So anyway, you can see now that any variable with the always perfectly correlated with itself, it would explain why the dark green boxes, through the diagonal, it will be the ones with that will always correlate the most among itself because it's essentially the same attribute. But if you look at the rest, it is not as green as the same attribute that you're trying to compare with. But you'll notice one thing is that the overtaken positions total, right, has the highest Pearson correlation, right? So let me see over here what have been done. So there's one more item that we forget to put in, which is overtaken position. Okay, now that looks better. So again, if you look at the overtaken positions total, right, highest correlation for 0.38. If you look at the score, okay, score and correlation. So this is very close by. In fact, over here is showing us 0.42. Anyways, these are pretty much close to it. Compared to the rest is lower. So in terms of the score, it's highly, I would say the correlation with overtaken positions total, it is among the highest between the score and that compared to the rest of the attributes. So that would be an indication of overtaken position total would affect the score as well, right? So eventually, as you go through all this correlation, you can see how we can actually move on to the next part where we can see whether it is a dry or wet weather or whatnot. We can actually investigate this relationship using a box plot. So what we're going to do is we are going to open a new canvas, right? And inside this new canvas, you can see it is actually creating a new canvas for you to continue with your analysis. So eventually what happens is we are going to choose this few columns, which is the score, wet weather, and also the name year, right? You're going to click on pick visualization, and we're going to click on the box plot. So obviously that did not go well. Name year, okay. Let's see what's happening. You can see now that we can actually just rearrange the chart configuration. Hmm. Name, year, score, and wet weather.
It's correct. Sorry, Charles. It's correct
Yeah.
because there's no difference between the score, whether the weather is wet or not, within the race, because you're breaking out by within the race. So within each race, the difference is small.
Yep.
Yeah.
No, because eventually we'll be looking into the box plots. Oh, okay. Now I understand why. We have to put the name year into the detail box. I was looking at, I keep on looking at the next result here, which is what we're supposed to actually be getting, right? So eventually, this is the end result that we should be reaching to, where initially when you first click on the visualization and box plot, it would put the name here into a color, so you would get a whole scatter of stuff. And eventually, once you push the name here into a detail box, then this is where you would get the result. And what we actually see from this box plot is that the data set is pretty much indicated by the small horizontal line within the box. So these are pretty much the data, that is being distributed along the lines. And we can see that the mean fan score for the races with wet weather is quite a bit higher than the for races with dry weather, right? So like what we have seen from the hypothesis, if we have wet weather, most likely in terms of the fan score, the mean is pretty much higher. If you were to see from that, between the no and yes, right? So if it's a wet weather, you can see for those races that happen on the wet weather, the scores are actually higher on the median terms compared to non-wet weather. Of course, there are some outliers which are quite far outside the boxes. We can see that there are dry weather races with higher score results. But overall, in terms of the wet weather, we can simply do a we can actually show that it is a higher correlation that provides a higher score by the fans. So eventually what we're going to do, once we are done with this analysis, we can save this as correlation workbook. Okay, so now that we have saved it, we can get out from this page, get back to the home page. And we've pretty much concluded for lab number 4. Okay, just want to pause a moment and see if all of you are able to follow. Just quickly checking the questions, the chat. Yeah, well, it's pretty much clean. I guess it's pretty straightforward. I think one of the questions that Arnab has mentioned, while loading data, do I save rows to skip equals to 1? By default, it's 0, or do I keep it 0? Yeah, so like what Daniel has mentioned, if the source data has header row, then you can just skip it. Okay, so I guess we can actually move on to the next part, which is, let me just pull up the lab just to show you where we are at. Right, we actually finished lab number 4. So we're actually now at lab number 5. So lab number 5 is actually pretty much the bonus content where you could actually do more analysis for yourselves, like going through um, this information and have a look at the drivers and all that. So let's do that, right? Let's go into this workbook, which is the race analysis, and we can catch up from there. Okay. Okay, I am going to go to my race analysis. So now we'll probably just want to look into the Brazilian Grand Prix. Like what we have previously, we have this too. So since I just won Brazilian Grand Prix, I can just click on this to remove it from the selection list. And if we just look into Vettel, this is pretty much his, his positions across the laps, right? And it's pretty much telling you that due to one of the recent collisions, so Vettel pretty much fell to 22nd positions early in the race due to a collision. So it's pretty much talking about this falling trend here. And you can see that um, eventually he made a good comeback, right? So initially when there's an accident, he fell all the way back here. And eventually he's able to come back again, you know, and head on to it. So that is also the time where he actually won the race eventually, right? So to give it a think about it, could we use this type of pattern to predict the score of a race? Well, I would say pretty much it. So because a large comeback, especially from many positions gain of a driver, actually does have a positive influence on score. So although we do not have the matrix available, but we'll have to create it ourselves later under the feature engineering, right? So if we look into the next task, which is the pit stops, it is asking us to remove the selection. So let's look at the Austrian Grand Prix of 2021. So we're just going to remove all that. Tribe Austria 2021. Okay. So now it says that we want to see whether there is a driver that made a pit stop in a particular lab. So instead of using the driver reference, we are pretty much going to change that into a pit stop, or we're going to add it in there. Let's try that. Let's click on the lab times, choose the pit stop, put it into the shape, right? Let me just readjust this. Yeah, so it's easy on the eye. Okay. So you can see that there are now, since I've actually put the pit stop under the shape, you can see that if it's a pit stop, if it's yes, meaning that there's a pit stop. If it's a no, then those are not the pit stop, right? So if we click on Norris in the legend, right, you can see there's actually a pit stop happening for Norris along at the lab number 30. So again, over here, you can see these two things. One is an actual overtake on the track, and the other one is a semi-overtake during their pit stop, right? So based on the results, notice how Norris is overtaken by Bottas in lap 30. So around here, yeah, pretty much that is the case. But this overtake took place because Norris was making a pit stop, right? This is in contrast with the overtake by Hamilton in lap 20, which pretty much actually takes place on the track itself. So the thing is, how do you believe pit stops can help us predict scores? Now, based on theory, you would say that although an overtake during a pit stop can be interesting, the overtakes that actually take place on the track are even more exciting. And of course, that will result on a higher score. Again, another note that we can put in is that the position changes due to a pit stop may be less interesting for viewers than position changes on the track, right? So again, this will be another consideration that we can put into the feature generation when we create our custom machine learning model. So as we move along, we would then see there is, for ghost cars, let's take a look at task tree, right? So in task tree for the ghost cars, we actually want to create a calculation and also a filter. But we're going to head back to only the Brazilian Grand Prix, and we can show you how that happens. Okay, so now once we choose the Brazilian Grand Prix, we're going to add a calculation here, okay? So you have the capability to, sort of add a custom calculation. And in any case, let's see what works for us. I'm going to drag the median milliseconds cumulative, right? So we're going to minus that from the milliseconds cumulative. So this would pretty much be the data for Delta to Ghost car, right? Click on Save. You will now have a new information you'll be able to drag in, and look into the results. So I'm going to be needing the lab, the driver ref, and also the Delta to Ghost car. And click on the, pick visualization, and I'll choose the line. So this is going to be very interesting, right? Now we have this result. You can see that at a point where there's a convergence, right, on the horizontal axis, y equals to 0, any car that is above the line is going faster than the ghost car. So any car below is going slower. So you can see that there is actually an event around lap 25 to 30 where all the cars come back closer together. Well, pretty much this is likely a safety car that was not visible before the position chart, and pretty much make us think, what could a safety car mean for the level of excitement of a race, right? The safety car effectively resets the race by compressing the cars into a short distance from each other. Well, the other theory that we can think of is that in general, this may also lead to a higher score. So another factor to take note, presence of a safety car may actually increase the score of the races in general. So now with that, I'm just gonna save this data and we can move on to the next part. So I would say that in conclusion, based on some of the analysis that we did, we actually, able to find several factors that influence the score where the fans will give to a race, right? And these factors were, actually available directly inside the races data set. Now that we have come across all this information, we can go on to the next piece where we do a machine learning capability, train the data, and do a prediction on the following year. So let's head on to lab number 6. So let me just bring up the lab guide. We have pretty much completed most of the lab 5. And we can actually start off the most interesting piece here, which is creating the ML model, right? So we will have some administrative tasks that we need to do, especially setting up the ML user, right? So let's get on with that and head back to the Oracle Cloud, head on to the Oracle database, autonomous data warehouse. Now, I need you to go into this data warehouse that we have created and been using. Click on to tools. You can actually go to Service Console as well, but essentially they're the same place. You can get the same, I would say, the place to do the configuration. So click on the tools, click on to Oracle Machine Learning User Administration, and we will go to the administration page. So over here, what you need to put into your username and password is the admin username and password for your database, right? So that will be the initial one that we have set up, which is admin. And I hope you did note down your initial password when you first created the database. So I'm going to sign in, right? Once you have signed in, you would see the admin users here. And we're going to click on Show All Users. And you'll see we are going to grant access for machine learning capabilities for F1 user. So let's click on the F1 user. Right? And you can actually put your name here and all that. So I will put my username, which is, this is my email address, and eventually just click on a save. So once you have click on save and it finished loading, you can see now your role is the developer. And you can actually now log into the Oracle Machine Learning with this username, right? And also the password that you have actually created previously, you would have to use that same password as well. So yeah, let's do that, okay? So what I'm going to do is I am going to head back to home, right? Just make sure you click on this house button on top. Head on, it would then pop up over here. Click on F1 and pop in your F1 password. Click on sign in. And now you can see we have logged into the Oracle Machine Learning. So this is where you can leverage on the machine learning capabilities by using the data that is stored in the autonomous data warehouse. Now, before we even do that, if you look into the Lab 6 task 2, there's actually in step 1, you have the machine learning notebook. You can very well download this notebook and we can then upload it into the Oracle Machine Learning portal here, right? So eventually, what we can do is click on Notebook and click on Import. So most probably I would have a notebook sitting around, which is the Red Bull Notebook JSON. So I'm going to upload it. So once you have uploaded, you can actually click on it and it would open the notebook for you. So this notebook is pretty much for you to inspect most of the data that is residing inside the autonomous data warehouse. As you can see, you can actually click. So at the very initial stage, you will have the SQL scripts. And once you run the SQL scripts, it will give you some results here. But these are pretty much the old results. So let's try and run the whole thing, right? Um, yeah, we'll be able to run the whole SQL by clicking on the play button here. So it will run every SQL that appears in this notebook. And the results would then be populated out for you to see. So once the result has ran, you can see it took 10 seconds and last updated, which is the most recent date and time. So the same goes with the rest of the SQLs here. So you would execute all these SQLs, provide a sort of, I would say, readjust the tables and all that to give you, a more suitable data set to do predictions on your machine learning. So overall, once we're done with running the notebook, we can actually try to train the model using AutoML, right? You can actually head on to this AutoML feature here, click on it. So now we can click on Create. So probably in terms of the name, I will put it as a predict name score. Predict race score, I mean. Okay. Next up, in terms of the data source, we will be selecting from F1, and we'll be choosing the races train, right? So pretty much this data that we have here holds the table, holds the record for the races information up to the end of 2019. So in terms of the prediction, we should be selecting the score because we want to know what is a score. Regression, prediction type remain as regression. And the case ID will be race ID. Now, this is where we actually control what are the factors that we should consider when doing a training on your data. So by creating a machine learning model, we would have a set of data, but inside the data, there will be some factors where we have to eliminate or include in order to get a more accurate, I would say more accurate results, right? So there is one option here called additional settings where we have to change this model matrix to use negative mean absolute error because this is actually the measurement of how close the predicted values are to the actual values. So the rest of the options here, nothing much required to be changed. So I'm just going to close it back, and our main priority now is to configure the input variables. So basically what we need, we will need the circuit ref, DNF count, DNF due to accident count, labs with changing positions 1 and 1 to 5, maximum comeback, overtaken to pit stop, overtaken position real total, safety car, right? And also the weather wet. Okay, so I think we pretty much have all the variables that we want to use. I think we have one more, which is rank versus position. Okay, let's add that in. Okay, we're good to go. So now we can actually save this AutoML configuration and have it run. So I'm gonna save it first. Okay, now that you have saved it, we can actually start the algorithm by clicking on faster results. So I'm just going to click on faster results and it would start, doing the machine learning. You can see here, this is the progress bar. It will tell you what are the stages and uh, whether that stage has been completed or not. So you will go through all of this algorithm, selection, sampling. All of this will be done automatically for you instead of you manually testing it out. It would look at what would, provide the highest accuracy from there on. It'll probably take a short while before it finish running all of this sampling, selection, and so forth, especially on the model tuning part. But eventually, once it does, we can use any of the ML models for that. Okay, one last part. All right, we have eventually finished everything, feature prediction impact as well. So along the way, you would see based on the lab guide, we are going to take note of the generalized linear model, which starts with GLM underscore and so forth. And as you can see, in terms of the features, these are some of the features that has been selected, and also what are the mean max values, the standard deviation as well, right? So eventually, once we have these results, you can say that we are good to go in terms of predicting the outcome for the following year. So just take a note in terms of this generalized linear model because we will be importing this into the analytics cloud for the prediction. So now let's go into the analytics cloud and we can actually add these features in. But before we do that, let's head on to task number 4, where we add the generated features to the race data. So let's get back to the race analysis. I think we're done with this. So let's go to the data. And I believe we should be heading to the races, right? Right click on this, click on open, change the edit definition. So actually, when we ran the notebook, there are actually several new fields that has been created inside the database table. But because we created this data set initially compared to the one that we ran in the Oracle machine learning, so some of these columns are not available at the selection part. So I think now we can actually click on Add All to include all of this selection here, right? So we have things like labs with change position 1 to 5, all these additional fields that has appeared, we have actually added into that as well. So click on Add All to add them all in, and we can preview the data. Okay, we have all the data in as well. That is great. So yeah, let's get on to the next part. Click on OK and click on Save. So now that we have saved the data set, we can actually move on to the next part. So what we do now is to import the machine learning model, right? By clicking on this triple dots here on the top left, top right, click on Register Model, and you should be choosing the machine learning models here. Choose the connection from your database, which is the Red Bull. And you can see there is quite a number of different machine learning models, but the one that we took note of is the GLM underscore. So this is the ML model that we plan to use, right? So let's register this. Probably we should also change the name into something more familiar or not. No, that's fine. All right, let's do that. Register this. Now we can head on to the data flow, okay? So click on create, click on data flow, and most probably we'll be choosing the races data, add it in. So now we should drag a filter because we might not need most of the data. In terms of the year, we can put 2020 and 2020. So again, we are going to drag apply model, right? Choose the machine learning model that you have registered earlier on. So now that you have one column called for the output called prediction, right? Um, you, if you know, usually if everything is well, there should not be any further actions required because most of the data has automatically been matched up with the input parameters of the model. So as you can see in the inputs here versus what has been matched. Not sure why it's not showing all, but yeah, this is the model's inputs, and this is actually the input from your dataset races. So it is pretty much matching with the same name and same columns. Yep. So eventually, like what I've said, we can then select some of the columns out, right? Over here, you can click on this plus button and choose select columns. So there will be four things that we want to select out, which is the race ID, name, year. Let's just remove everything because we only need a few. Race ID, uh, name, year, score, and prediction. Let me just do something different. Race ID, name, year. You can hold the control button so you can just select the field that you want to add that in, and also prediction, right? So you can see it is being highlighted in the blue colors. Just add the selector in. So now you have four here. And lastly, we should be adding a saved data set as well over here. right? So this is the scores that has been predicted from the machine learning model. Anyway, we will have some logistics to change here. Well, first things first, we're going to change the data set to predicted scores. Right, we're going to verify that the treat as value for each column is set as in a screenshot. Okay, so in terms of the race ID, yes, it should be an attribute, measure, sum. Okay, yep, I think that should be it. Put the table name predicted scores. Right. So now we're going to save the data flow. So what it actually did was save this data flow so that next time if you wanted to run it again, you can come back into this data flow and trigger it to run. But in order to make it run, you actually have to click on this play button here, which says run data flow. So let's do that. Okay, the data flow is now running. It should not take long. I would say for this data set, it's not that large, probably a minute or less. Eventually, you'll see a message saying this data flow has actually complete. And this is where we could get back into the analytics cloud to evaluate the accuracy. All right, now it says this has completed. We can just head back into one of the notebooks. So let's go to predicted scores, right? Click on predicted scores. We pick all of this as well. Have a visualization up, line chart. Oh, it's annoying. Anyway, score and prediction, we should be on the same side. Race and name year should be under category. Okay, now this is the result that we should be expecting, right? So you can see and notice that how the predicted scores follow the actual scores nicely. So this is the one with the dark blue or dark green line is actually the score, but the one with the orange line is actually the prediction of the score based on the features that we have used to train using the machine learning model from the training data sets. So in terms of the deviation, it's not that far. I would say it's pretty close, maybe except on these two different areas or different races. But other than that, it is quite close to it. So let me just save this, call it as check prediction accuracy, okay? Well, we still have a little bit more time, so why not we finish the last few bonus content here, which is bonus exercise. So on task number 8 for lab 6, it is actually talking about how can we calculate the difference between the predicted and actual scores. So yeah, let's do that. Again, it's a simple calculation, add a calculation, choose the difference between prediction minus score, prediction minus the score, and we can name that as distance, right? we can now drag distance into the y-axis and have that change probably into a bar chart. So let's just do that. Click on this distance and you can choose any of that visual that you want. We'll be going for the bar chart. There we go. So now you can see that the predicted score follows the actual score in general. I would say it is a pretty good initial result. And for a point of improvement, you could notice that how on the races with lower actual scores and the predicted score tends to be a bit on a high, right? But overall, it is a good mix in terms of the difference here. Not too far deviated among the actual scores as well. So I think the last content here is to task number 9 is pretty much like for you to predict on the scores for year 2021. And yeah, based on that, you can see that adapt the data flow for, to predict the scores for 2021. And eventually we'll be able to create a prediction out of that. So I will leave this last task here, task number 9, for you to figure out the results that you can see on screenshot number 2. And eventually we can conclude by utilizing all these data from the previous Grand Prix data along with Oracle's machine learning capabilities and also Oracle Analytics Cloud paired in with the autonomous data warehouse, you are able to do machine learning much easier with a very simplified workflow where you're able to import your machine learning into the OAC or the Oracle Analytics Cloud and have it run through a very simplified graphical user interface experience. So I would say we have pretty much, come into the factors where we found that in terms of the takeovers, there's actually an important factor for the race score, right? Weather also plays a very big factor in terms of the excitement of the races, the less deviation in the weather in terms of, not having wet weather and so forth, then the excitement might not be as great. But eventually, all these factors pretty much add in to the scores. And this is how we can leverage on Oracle solution to predict scores and also results for future, events as well. So I guess that is pretty much it. We are pretty much done with this whole lab session here. And I guess, thank you so much. If I were to check in the chat, no questions. I guess all of it is pretty much straightforward and easy to understand. Thank you so much for attending this hands-on lab session. Hope to see you all again in the next one. Thank you.